And we're back. All right, let's do number 7. Okay, number 7, it says, it is 2019 and you invest $1,000 into an account that pays 1.4% monthly interest. How much would your account be worth in, what the heck, in 2025? All right, so we're going to use our A equals P times 1 plus R over N to the N times T. Okay, N, if it's monthly, is 12. Okay, our rate is 0.014. All right, 0.014 if I divide by 100. Okay, this is our P value. And then what will be worth in 2025? Well, if it is 2019, then in 2025, it's been 6 years. Okay, so I'm going to throw what I know. A equals 1,000 times 1 plus 0.014 over 12 to the 12 times 6. Alright. I know there's a couple ways we can do this in our calculator. I think the easiest way to do it is piece by piece so that you don't make a mistake. Now, other people may, Ms. Logus might have done something differently and just plugged it all in. That's totally fine too. I like doing it piece by piece, just like I'm doing right here for you. Okay. But that's my preference. Obviously, you go with what works best for you. Okay, you go with what works best for you. So I'm just showing you what I would personally have done to find this answer. Okay, that's what I would have done, and I got 1087.58. All right, obviously you can plug it all in at once. It doesn't matter. I mean, it's your work. Okay, I just showed you how I did it, and there are other ways to do it. My way is not the end-all be-all by any means. I am not, I am no, like, genius, you know, I guess. Maybe not, I don't know. Maybe someday, you never know. You never know. That's a 0. Hello. That's a 0. Okay, so the next part of the question asks you, in what year, so in what year? So that means we're trying to solve, okay, in what year means, oh my gosh, there you go, T equals question mark. Will my balance be $5,200? So this is my A value. So I'm going to work backwards-ish. So I set 5,200 equal to 1,000 because that's still my initial investment times 1 plus the rate is still 0.014. The N is still 12. 12 is my N still. And then T, I'm just going to leave as T. Okay? T is just going to be T. Alright? Now, next, I'm going to divide the 1,000 first. Get it out of here. If it lets me write 1,000. Okay, so I get 5.2 equals, and I do this 0.04 divided by 12 plus 1, and I get 1 point. And you should write all the decimal places. You should write every single one, or as many as possible. Okay, so there's 2 ways you can go about doing this. I'm going to show both methods. Alright, the first way you could do it is take the natural log of both sides. Take the natural log of 5.2 equals the natural log of 1.000, whoops, too many zeros, 0011667 to 12t. And like the reason I do this is because I have a variable in my exponent. Well, if there's an exponent within a log, our properties say we can drop it down to the front. So I get 12t times all of this, okay, equals ln of 5.2. Well, I'm going to divide by a natural log of 1 point dot 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 dot. Do that to both sides. Okay, and get some number, and then divide that number, whatever this is, by 12. So what I mean is you'll do this. The ln of 5.2 divided by the ln of 1.001167, enter, and then take that answer and divide it by 12 and get your word. Okay? Or you can also do it a different way, where I can take this here and put it into logarithmic form. So log is a log of 1.0011667. Jeez. Of 5.2 equals 12t, and then figure this out, and you'll still get the same answer. You should still get t equals 117.8, which is basically 118. Okay. How I would do this in my calculator here, I would do the log. Depending on, like, if you have a newer calculator, some of them allow you to change their base, some of them don't. But if you have to use the change of base, you're going to want to do this as my change of base formula. Okay, I can do it like that, and then still divide it by 12, and then I'll get the same. I should get the same thing. Why is that not the same thing? Whatever. I'm not going to even. It's the same thing. You should get the same thing. All right. You just got to trust me. So, in what year would that be? $5,200. Well, I would take 118 and add it to 2019 and get 2036. I can't with this pen anymore. I'm just going to freak out. I'm going to break it. I'm running slowly. 2036. 21. It's not my day. I found my mistake here. I left out a 1. Alright, so then I still get the same answer here. Okay. And you should get 2136, 2137. Holy buckets. There's no way I'm going to finish 2 problems in 1 and 2 bit. Okay. Anyway, so, alright, we got a rational function here. Okay. First thing I want to figure out, first thing I want to do obviously is to factor and simplify. So I'm going to take out a 3 and have x squared minus x minus 12 over x plus 3 x minus 3, alright, equals 3 times x minus 4 x plus 3 all over x minus 3 x plus 3. Okay, so my x plus 3's cancel, which means I'll have a whole at negative 3. Alright, that also tells me I'm going to have to substitute negative 3 in for x anywhere I see an x. Okay, and you should get 21 over 6. Alright, next thing I'm going to take care of, this is an x minus 3, right? So I want to figure out, all right, what's my vertical asymptote? My vertical asymptote is whatever is left over in the denominator. Okay, whatever is left over in my denominator, and I'll set that equal to 0. So I take my leftover factors, which is just x minus 3, and set that equal to 0, so my vertical asymptote is x equals 3. All right, domain, remember, what can x not equal? Well, if I have a whole at negative 3, then x cannot be negative 3. So a lot of people make that mistake where they forget to include the whole. Okay, so I go from negative infinity to negative 3. Alright, so I go from negative infinity to negative 3 because of the whole, negative 3 to 3 because of the vertical asymptote, and from 3 to infinity. Okay, horizontal or end behavior asymptotes, is it top heavy, bottom heavy, or even heavy? This is an even heavy problem. Okay, degree on the top matches the degree on the bottom, so that means I'm not going to have a slant asymptote. I would write none here. Okay, but my horizontal asymptote is going to be y equals, if it's even heavy, I'll have horizontal. Okay, leading coefficients, a ratio, 3 over 1, which is just 3. So I'm going to go ahead and graph that. Or at least attempt to. And I'm going to graph the x as well. X equals 3. And at least attempt to. And I got negative 3 and 21 over 6, so it's probably like somewhere in here. That's a whole. Okay. X-intercepts. X-intercepts, I take my leftovers in my numerator, so here, and set it equal to 0. So my x-intercepts the only x-intercept I have is 4, 0. Okay, so I'm going to make that dot for myself. 4, 0. Y-intercepts, plug in 0 for my x. So if I plug in 0 for my x from my original, all right, I get 0 minus 36 over 0 minus 9, so negative 36 divided by negative 9, which cancels out, and that's 4. So I also have 0, 4. Okay, make that dot, boom, connect our dots. The best I can. Alright, I'm going to do my best here. This is a little jumpy again. Alright, there we go. Okay, for the sake of time, I factored and solved this for you. I took out a 2x squared as my greatest common factor. Remember, whenever you factor, you need to ask yourself, is there a GCF? Take out 2x squared. Okay, and I'm left over with x squared minus x minus 72. So that becomes x minus 9, x plus 8. So here I get 0, 9, negative 8. So these are my critical numbers. Alright, if it's greater than or equal to, I can fill in my circle here. Alright, so that's negative 8. And I'm just going to rough estimate. I'm not going to count out 0 and 9. So remember, you have to check each interval. I have to check each interval. So I got to pick a value less than negative 8, so I'm going to pick negative 10 and check. If I plug in negative 10 here, I'll get a positive answer. If I plug it in here, I'll get a negative number. If I plug it in here, I'll get another negative. For overall, a negative, which is not greater than 0, so that does not check out. Okay? I'm going to plug in a number in between here. I chose, what did I choose? Negative 1. Negative 1 will give me positive, negative, positive. So positive, negative, positive for an overall. Oh, this should be positive. Oh, wait, holy buckets. Sorry, this would have been a positive number, which would have checked out. I plugged in negative 1. I got positive, negative, positive. Gave me a negative. Not going to check out. Plugged in 1, positive, negative, positive. Negative number, I plug in 10, I get all positives to give me a positive. So this interval works and this interval works, and I want to write my answer like this. I put the bracket since it's equal to. Holy cow, I just made it. Deuces.